Assalamualaikum warahmatullahi wabarakatuh. So, Bismillahirrahmanirrahim. So, let's start the new chapter for today. That is chapter 8, operational amplifier. Okay. So, what you're going to learn for this chapter is, the first one is, what the keyword here is operational amplifier. In the short term, we call this one op-amp or op-amp. So you're going to learn what is the characteristic of the ideal. Ideal is the perfect op-amp without any interruption or distraction in the real life. So then we have the data sheet of the op-amp. So in this case, we call the LM358 is actually an IC, integrated circuit, and the code of this IC is LM358. What is actually LM358? Is actually your op-amp. So it has, I think, 8 legs here, 8 pins here. So inside this a lot of transistors. So it have been packaged and we call op-amp. You also will learn the type of op-amp, that is inverting and summing. So integrator and differentiator is additional knowledge for you. It will not be covered inside the syllabus. So you may go through by yourself. And how we're going to apply this op-amp inside your real life. So that's what you're going to learn for your today's chapter. Okay, when we are talking about op-amp, so O-P-A-M-P, right? It's actually amplifier. So what is the purpose of amplifier? To increase the voltage without changing the shape. Means if your input is a sine wave, your output will only change the amplitude without change it to the another wave. So the shape will remain, but it only increase the amplitude. So where is the op-amp play role here? Here is your op-amp. So amplifier is active or passive. Amplifier is an active device. So what does that mean by active? You need this DC power to turn on your active device. And once it is turned on, you can do the amplification where your input comes from either from temperature, from acceleration, from magnetic field or radiation. It's a small input. And then this input is a temperature, right? So when it is a temperature, you need to translate this to what the electronic circuit can read. Either it is voltage or current. So in order to translate the temperature to voltage or current, we call this one transducer. It will translate temperature, radiation or acceleration towards voltage or current. When it reaches here, the voltage that we receive from this sensor, let's say this is a sensor, is microvolt, is 10 power of minus 6, it's very small. So you need to amplify this voltage to become millivolt, 10 of minus 3, or become to the volt. You need to amplify it. So in order to amplify the voltage, you need amplifier. So that's where this op-amp works here. So the output of this amplifier will be amplified from micro or millivolt to maybe a voltage. So how you're going to display your output, you need to use your oscilloscope. So this is where the data will be analyzed. So op-amp or amplifier play a big role here, where from your sensor, the output of your sensor is a very small voltage, and that will be translated to the to analyze the data. So your amplifier need to have a very stable gain, high linearity, and low output impedance. Okay, so now what is actually op-amp? Operational amplifier. The role of op-amp is to perform many mathematical operations. So you can have a summing amplifier. You're going to invert the amplifier. Let's say your input is like this, so your output will be inverted, or your output will be remain the same. So all this is what we call mathematical operation. You can add, you can sum, you can integrate, or you can differentiate. So this is what we call operational amplifier. So it is a building block of the analog circuit. Why we call analog circuit? Because your input here will be a sine wave or a cosine wave. It's the AC inputs, okay? And you have two input. One we call inverting, because it is connected to the minus. Another one is called non-inverting. So this triangle represent your op-amp. So the output will be only one that is connected to the end of this triangle. So in order for you to make sure the op-amp works, you need to apply a power supply. So it is active or passive. So op-amp is actually active device. So do you need DC or AC power supply? So here you need DC power supply. Okay, so as shown here again, op-amp is a triangle block. So we have how many input? We have two input. One is non-inverting connected to plus, another one is inverting connected to minus, and you have only one output. So since op-amp is a active device, so you need to have a two supply here. So the supply here will be connected to DC supply. So you have here plus, and here also DC supply minus, because this is an active device. Okay, so let's move to the op-amp equivalent circuit. What does that mean by equivalent? Equivalent, why we need equivalent? Because we want to simplify the circuit. Does the circuit really exist? No, it's just for simplify the analysis. So in your previous chapter 1, you learned about voltage amplifier equivalent circuit and current amplifier equivalent circuit. For voltage amplifier, you relate with Thevenin. Current amplifier, you relate to Norton. Okay, so if you see this circuit here, we have Ri, we have R out, and then we have a dependent source. Have you seen this circuit before? So this circuit apply to chapter 1. How you can relate this to chapter 1? So if you want to relate this to chapter 1, this is actually a voltage amplifier. So remember, voltage amplifier, you only have three elements. The first one is R in at the input, and then at the output you have R out, output resistance, and then you have a dependent sources. These dependent sources in chapter 1 is actually AV/VI, right? So what is AV is the voltage gain here. VI is VD is the voltage across here. But in this case, for op-amp, you have two input. One is V2 and another one is V1. So what you need to do is you need to find the difference between two voltage. So we call this one V2 minus V1. Okay, so how are you going to find the gain for this circuit? This is what we call V2 minus V1. What is A here? So remember how you relate this to chapter 1. A is the open loop voltage gain. Open loop voltage gain. Okay. And then how you going to find the gain? What is the gain? Gain is actually output over input. So your output here is V out. Your input here is the difference between two voltage. So it's actually V2 minus V1. So this is the open loop voltage gain of the equivalent circuit of the op-amp. Okay, now let's see how it will be interpreted into a circuit, means into an integrated circuit. So this is an example of the integrated circuit of op-amp, where we can have LM741. So as explained before, we have 8 pins here. So now the important pin here is this one. This is the supply, because op-amp is an active device, so we have two supply. One is V plus and one is V minus. So you need to connect this one to DC supply. And another one, where is your input? Input is connected to pin 2 and pin 3, and your output will be connected to pin 6. Okay, so in the next video, you will learn about what is the ideal op-amp characteristics. So let's stop the video, the first video for today. Assalamualaikum.